Hey everyone, welcome back to Designing AI for Humans. In the first episode, we explored how software shifted from predictable code to probabilistic behavior and what that means for how we design and build the software today. That episode was about understanding the nature of intelligent systems, the shift from the default software technology of the previous era to the probabilistic choice oriented AI technology. This episode is about understanding how AI actually works, how these systems work beneath the surface, because once you know what's happening inside the model's mind, you can start to see why AI behaves the way it does. And then you can see why these mechanics matter for anyone building AI products, interfaces, or experiences today. So let's get into it. You've probably experienced this before. You ask ChatGPT, Gemini, or any image generator like Midjourney for something, and the first answer or generation seems perfect. Then a few messages later, as you keep interacting with it, it suddenly goes off track. Sometimes it completely forgets what you told it at the beginning of your conversation, like the role it was supposed to play or the context of your task. And later, it gives you a response that feels entirely different from what you asked it to do. Sometimes it will even hallucinate. These are the points where the user experience breaks. Here, the model is the experience. The interaction between the user and the model is the user experience. And this is where model design shows up. When users are experiencing these moments of frustration, when the model is hallucinating or not responding in the tone or in the context of the task which the user had provided, the experience is breaking. But here's the real question we should ask. Why does that happen in the first place? Because if we don't understand why, how can we, as designers and product builders, possibly build the AI systems that prevent it? Only when we understand why it happens, we can design for a good user experience. So, if you want to build AI systems or AI tools, you need to understand these mechanics. Every time you write a prompt, you're not talking to something that reads or understands like humans. You might give a very detailed prompt to an AI tool, but it does not read it the way we do. So, how does it read? You're engaging with a system that's doing three things behind the scenes. Every single time you give it a prompt, it's breaking your words into smaller fragments, which are called tokens. It's holding them inside a limited memory window, and it's deciding which parts to focus on first. This is an invisible process that's happening in the background every time you send a prompt to the model, and the model perceives and makes sense of everything you give it and then responds. This whole process is shaping the consistency and quality of every AI conversation. And this is why it's so important to understand. If we do understand it, we can design products that feel contextual and human. In this episode, I'm going to explore these three mechanics: how the model sees, how the model remembers, and how the model focuses. And I'll explain how each one directly influences what users experiences in your product by connecting to a product pattern. How it sees, that's tokenization. How it remembers, that's context windows. How it focuses, that's early token bias. These three form the cognitive architecture of language models. This is actually not about technical details for their own sake, because only when we understand these technical details, we can design the intelligence. Once you know what the model can see and cannot see, how much it can remember, and how will it prioritize the information, only then you can design the products that feel natural. When you and I read something, we see words, we read them together, and meaning forms in our mind, the structure, the tone, the flow. But a model doesn't see the words the way we do. When you give it a prompt, it breaks everything, every word, punctuation mark, and space into small fragments called tokens. So all your text, whatever you have provided in the prompt is turned into a chain of these little pieces. If you look at the example, designing with AI is fascinating. We read that as 6 words and perceive it as a meaning. The model don't. Internally, it might see something like designing with AI is fascinating and a full stop. That's how it reads your input as a sequence of tiny building blocks. Whatever the text you type, the model breaks it into smaller fragments called tokens. And each of these tokens then turns into numbers. This is the internal code for meaning inside the model. And when you provide a prompt, the whole prompt words are converting into tokens, and then they are converting into token indices in format of numbers, and then it's getting stored in form of vector indices. All these vector indices live inside a massive semantic space. Think of this semantic space, which the model thinks like a 3D map where similar meanings sit close together. Words like swim and swam, or work and pens stay close. King and queen sit close. Happy and joyful sit close. But engine and flower live far apart. The model doesn't know the meaning of design the way humans know. When you say designing with AI is fascinating, it is not understanding design like a human. It is turning design into a token, then into a number, and placing that number in this vector space. It just knows where that token lives on this map and what usually comes next. So, whenever you are interacting with the model, it is generating or predicting the next word, basically the next token. It looks at nearby tokens in this vector space, and based on the context, what you have provided so far, it assigns a probability score, often called an attention score, to all the words that might come next. So the word, which is token with the highest score, is chosen as the next output. When you say the sky is, there are many possible next words: limitless, blue, red, cloudy. All of these are somewhere residing in that vector space. Based on the context, the model might pick blue because of the highest attention score it has. So models don't really read words. They predict the next token, and it will output in form of a word which can be understood by human. And this is all probabilistic choice. We explored that deeply in episode 1. Now, why does this matter for us? Why do we need to know about the tokenization? We are designers and product builders because every token we send to the model, which means every word or punctuation which is included in the prompt, the model carries three things: cost, latency, memory. Most businesses use these models like GPT or Gemini in their tools through APIs. Whether it's GPT, Claude, or Gemini, every model API charges based on tokens. More tokens means higher cost per request. So if your system prompt or your user input is long, you're literally paying for every extra word. Second, latency. Longer prompts take more time to process. It's like giving the model a bigger pile of Lego pieces to arrange before it can answer you. So it needs to arrange those pieces which are in your prompt, all the tokens, and then it should respond to you. So if your product sends long, redundant prompts, users will feel that lag in the response time because the model needs to understand those initially. Third, memory space. Every model has a limited working memory. Each token you send consumes a bit of that space. If you look at the ChatGPT API pricing page, which is over here, we do have different models within GPT-5, whether it's GPT-5, GPT-5 Mini, Nano, or Pro. Each model has a different price for both input and output tokens. Every model API bills per token. More tokens means higher cost, slower responses, and less effective working memory. That's why I call this as token economy. We need to express intent with just enough tokens, not more, so that we can save the cost and save the time. When your system prompt is huge, it quietly eats into this memory budget. Adding more tokens means less room for what really matters: the user's input, the conversation history, and follow up context. Let's say you're building an AI writing assistant. You have given it a default system prompt that defines the tone and the role, and it's 500 tokens long, which means maybe 10 sentences, roughly. Now, a user comes in and provides a long article or a detailed prompt. Now, the model has to fit both the system prompt and the user prompt inside its context window. It needs to remember both these things to provide a user response. If the context window, how much ever the model can remember, if that overflows because of the length of the system prompt and the user prompt, it doesn't follow the instructions what you have defined or what the user had defined exactly. It starts forgetting or ignoring parts of the input. So every token you use affects cost, latency, and memory. Every AI product is paying in three currencies: tokens, latency, context space. We need all these three to create best user experience from the model. Now let's take a simple compression of a prompt example. Let's say your system instruction says, write a friendly and professional summary that focuses on clarity, accuracy, and relevance. We could simplify this prompt into summarize clearly and accurately in a friendly professional tone. It's the same meaning, but fewer tokens, which I mean is fewer votes. This makes the response faster, cheaper, and leaves more room for the user's prompt. If we rewrite lengthy system prompts with token economy in mind, we can save a large number of tokens and reduce the cost for the business without losing the intent. But there's one thing to remember here. Fewer tokens don't always help. If we are compressing the prompt a lot, the meaning could be lost. So compression must preserve the intent. Now, how can we build this into the interface, into the human AI interaction layer in our products? Imagine your product doing this automatically. You have a little auto prompt or prompt optimizer icon in the way which you are seeing in the current image. The user comes to the tool and he can write the prompt in his own natural style. The system rephrases it to be token efficient when the user clicks on auto prompt or prompt optimizer. So the system can do two things. The first one is rephrasing the user prompt into a shorter, clearer version that uses fewer tokens. This is going to save the cost for the business. The second is rewriting the prompt into a structure the model understands really well. Maybe we turn the user prompt into an adjacent format or a consistent template that model can understand very well. By doing that, you reduce tokens, thereby cost, and at the same time, you give the model a good representation of what the user needs. So when the model gets a better input representation, the output of the model also comes back in a clearer, more reliable format. So the model is providing a much more better response to the user, thereby increasing the user experience better. This is what I mean by model design. Experience design for a token based mind, which is the model. As product builders, this is the first mental shift we have. The language is not free. Every word, every adjective, every repeated phrase in the system prompt or the user prompt adds cost and influences the behavior of the model. When a user has a conversation with the model, with every user input and every chatbot response, tokens are getting added. From the first message, tokens add up really fast, and each ton of conversation spends the model's memory. But how much memory does the model actually have? How much can it remember? Is there a limit? If there is a limit, how much it could be? It's easy to hit the limit if we don't know the limit. And that's when context starts disappearing and getting ignored, and the model might provide different responses with which the user might not expect. This brings us to the second topic, context windows. Every model has what's called a context window. You can think of it as a short-term memory span. Everything that's part of your interaction, your system prompt, your user prompt, the previous responses in your conversation, all live inside that space at once. In one example here, you might see something like 4096 tokens, which is roughly 3000 words. That's the amount this particular model can hold at a time. That's its capacity to remember information in that interaction. As the conversation is progressing to more and more messages, the window slides forward, which means the context window is sliding towards the newer prompts and newer responses. As the new tokens are coming in, old tokens followed. That means the earlier parts of the conversation eventually drop out from the context window, which the model can remember. A simple way to imagine this is as a whiteboard. Everything you and the AI have said is written there. All the context, the tone, the goals, everything is written in the whiteboard. But we all know the whiteboard has a limited space. As new lines get added, we need to erase the older ones. In the same manner, the AI can only read what's still on the whiteboard, which is context window. After a long conversation or several regenerations, the model starts forgetting earlier details or shifts the tone. It doesn't mean the model is broken. It means the earlier tokens have literally been wiped off the context window, which the model is referring to. If you visualize it, the green area is what's inside the context window, what the model remembers, and the red area is what's already fallen out. When users interact with the model, they often treat it like a brain. They do not know the concepts of context window. They are not aware of the technical concepts. They, it's closer to a whiteboard that keeps erasing itself, practically. It's not a long-term memory system. When the user receives a response that ignores something they said earlier, it not only affects the user experience, it affects the trust in the product and the business. So we need to design for this boundary. This forgetfulness is not a flaw. This is a technical feature and it's a boundary for us. We need to design around this particular boundary. Different models have different memory spans, different context window sizes. Earlier models like GPT 3.5 Turbo, which had released in 2022 year, had context windows like 16K tokens. Then the models started getting improved. Then we got 32K, then 128K, then 200K. Newer models go even higher. So these are the latest models. Claude Sonnet 4.5 had 200K context window. Grok 4 has 256K context window. And the highest is Gemini 2.5 Pro, which is more than 1 million tokens. Even though these systems keep improving over the time, their capacity to remember is still limited, how much ever the large it could be. It's not infinite. Now, what if we just make the window larger? That sounds better, right? A larger context window. AI research is happening to increase the larger context window, and that's how we are able to reach 1 million tokens. But at the same time, larger windows are not always better. It's not so simple because irrelevant or outdated context can dilute the model's focus. The larger the window, the higher the cost and the greater the chance of irrelevant or outdated context creeping in. Higher number of tokens relates to higher cost. So as designers, we have to decide what deserves to stay on this mental whiteboard, which is within the context window, and what should be erased within it. Most users don't know that context windows exist. They don't know the technical terms. They don't need to learn about them. But they should feel that the system is managing the focus consciously. For example, This is from Gamma app, which is an AI tool for creating presentations. It shows a token counter, something like 120 by 4000 tokens. This is like a feedback. It tells me that I can still add more, which means that I can give the user prompt much more. I can add more sentences. I can give more instructions to the model. What I'm understanding by seeing this token count number is that I can give more instructions to the prompt and still it can respond better. Also providing assurance that the user can add more, which is empowerment to the user, thereby improving the experience for him. Maybe we could showcase a small bar that says context used 80%, or we can notify them that older parts had been summarized for clarity. These kind of little signals, little UI tweaks do something better for the users. They actually turn this forgetfulness, which is of the context window and the context limit, into transparency, that you still have more space to input your prompt. And this transparency builds trust for the user towards the product and the business. Behind the scenes, AI teams are already designing around these limits. They are trying to invent the ways that they can work around even within the context window limit with which what we have. How can we provide better information within it so that the user can receive a better response? There are three concepts which I want to give as a sneak peek. They chunk long documents into smaller sections and remember it. They summarize older conversations into short recaps, which means the whole conversation, what the user had so far, can be summarized and can be shortened and be placed in the context window. And the other concept is they could pin important details like username, tone, or project goals, something like very important information for that particular product, always keeping it in the context window so that the model always sees them and respond accordingly. The model's memory is limited, but the smart design can make it feel almost limitless. So far, we have seen how the model sees the language in the form of tokens and how it remembers within its limits context windows. But even inside that memory, not every word gets equal attention. So when you give a whole prompt, all the words don't have an equal attention. The model needs to focus on certain words to give a better response. Now let's talk about how it focuses, what it decides to pay attention to first. If you imagine a sequence of tokens, over here, if you could see the visual, the black tokens are what's already been generated or provided, and the green tokens are the ones which are getting generated, which means the next ones which the model is going to predict. Language models generate text from left to right, one token at a time. This is why you see the model will be responding one word after the other whenever you use any AI tools, especially conversation tools. That means what appears first, both in your input and in the model's own output, heavily shapes everything that follows, because the first few tokens act like an anchor. They set the tone, the reasoning style, and the overall direction of the response. This is because every word that the model is producing as output, it is based on the previous set of tokens, which means the previous set of words in the response. So if the previous set of words have been going in one direction, the next set of words are going to go in the same direction. This is what we call early token bias. If those first tokens are slightly off, the entire continuation of the response can drift. Let's make this concrete with an example. Take two prompts that sound almost identical. The first prompt is, you are a witty journalist, write a headline on AI plus fashion. The second prompt is write a headline on AI plus fashion, be witty. It's the same words, but you will often get very different outcomes to these two prompts. In the first prompt, the model starts thinking as a witty journalist from the first token because the first sentence you give to the model is, "You're a witty journalist." That framing influences every decision it makes next, phrasing, tone, even pacing. In the second prompt, "be witty" comes second sentence at the end. By that time, the model has already started generating a straightforward headline because the first sentence is write a headline. You might still get something clever for this second prompt, but it feels half committed. May not be as better as the first one. That's early token bias in action. What comes first frames everything that follows. Now, why does this concept matter for design or business? Because the way you order information in your system prompt and user prompt, and even in your product's input fields, if at all, if you're taking these input fields into the system prompt, those directly shapes how the model behaves or responds to the user. What you place first in a prompt shapes everything downstream. We can use this idea through what I call prompt scaffolding. Let's take a customer support copilot example. If tone comes first, say polite, clear, concise assistant, and the token appears early in the composed prompt, the model will anchor its generation of response to the tone from the start. If the tone comes last, the model has already started writing before it knows how it should sound. As designers, we need to structure the UI pins or the prompt to match the way the model reads, top to bottom, left to right. The visual order becomes the token order in the model design. If your system prompt starts with "you're a polite, helpful assistant who communicates clearly and concisely," that's role and tone first. Then you add the task as second. Assist the user with account related questions or issues. The model immediately locks into the right tone before handling details because you set role and tone in the first sentence. But if you reverse that, start with the task, you'll get answers that sound correct, but they might lack warmth or consistency. Details and constraints can come later in the prompt. These small rearrangements in the token order, which I mean in the system prompt or user prompt, can create very different user experiences because these will vary the responses the model will produce. Designers often think of UX as a visual order, buttons, forms, hierarchy. In the same manner as in the interface design, within the AI design, we have a second layer of UX underneath, that is the token order. This is invisible, but this is model design. It defines the model's behavior just as much as your interface defines the user behavior in the usual software. A simple design principle here is what's critical must come first. When you get this sequence right, your AI experiences from your model feel intentional. It will have a consistent tone, predictable structure, and it will even have fewer hallucinations and surprises. When you get it wrong, the model might drift and the output might start feeling unstable for the users, thereby breaking the user experience. This is actually not about prompt tricks. This is about designing the communication between humans and models more consciously. This is interaction design and model design coming together because the user is interacting with the model. Now, if you look at everything we have discussed so far, how the model sees, remembers, and focuses, you will notice that these three are not separate ideas. They're all part of one continuous system, one chain of thinking that shapes how every model behaves. Tokenization decides what the model can read. Context windows decide how much it can remember. Early tokens decide the order it should follow in the responses. If you think of building with the models, these three mechanics are your design materials. They form the hidden logic of the AI model behavior. If your system prompt is too long, It eats up memory space, leaving less room for user input. Then, as the context fills up, earlier tone instructions, which means earlier messages, get pushed out, and the model forgets the role or task it was supposed to play. Finally, if your tone setting tokens or role setting tokens appear too late in the prompt, the model starts generating in the wrong voice before it even reaches the constraint. So, what looks like drift or hallucination in the model responses, which we feel, it is not random at all. It's a ripple effect of how we design the prompt flow, which is the token order. The efficiency of your tokens affects memory and cost. Memory affects consistency. Order affects focus and quality of output. So, as we learn these three principles, let us try to put into practice when we are building products and designing the models. I'll give you three questions as a quick self check for whatever AI system or the tool you are building or working on. You can see this as a three-step audit, one for how the model sees, one for how it remembers, and one for how it focuses. First, tokenization. Ask yourself, how many votes or details does your system prompt really need? Are we seeing the same thing twice in slightly different ways in the prompt? Can I express the same intent with fewer tokens? Every extra phase or word in your prompt is adding cost and delay, and which is latency. Next, context windows. Ask, how much information are you actually sending to the model each time? Is it all relevant, or are you passing unnecessary history? Does your system makes users feel like the AI remembers the right things or that it's randomly forgetting? Try to test it, which is evaluation of AI models. We will discuss that in the next episodes. If your model's memory behavior feels unpredictable, that is a design signal. It's not a model problem. We may need to fix which tokens you send into the context window. And then early token by ask yourself, what is the very first thing that your model reads? Does your system prompt begin with the right framing, role, tone, goal, constraints, and so on? Are the critical parts buried at the end where they have less influence? The model's first tokens are like its first impression. They set everything in motion. If you run this three-step audit, you'll quickly see where small design changes can make big differences in the model responses. It will result in clearer prompts, lower cost for your businesses, faster responses from the model side, and more consistent behavior from the model, which can improve better user experience. We need to align our product's language, memory, and focus with how the model actually thinks. What we often call AI behavior, which is the model behavior regarding the responses, is really a reflection of our own design choices when we are designing these things. The model doesn't just drift on its own, it reacts to the setup we create. When we ignore those boundaries, the experience feels broken or unpredictable. If you connect all these dots, you will see that we are not just designing the interfaces for users, we are actually designing the thinking environment for the model itself. This is model design. When we align these two, the human experience, which is the user interface, which is on the surface, and the model's cognitive experience underneath, where all these processes are happening, that's when the product truly starts to feel intelligent and human. The model doesn't think like humans do. So we must design like it does. Once you understand how it sees through tokens, remembers through context, and focuses through order, you will stop guessing and start shaping. You stop doing trial and error and start shaping the thinking environment. Only when you truly understand how an AI tool is going to provide the responses, only then you can provide better prompts. Until then, you're doing a lot of trial and error and copy pasting different prompts. This is how we turn these AI features into real product experiences for the users. When we talk about AI design or the model design, it's easy to focus on efficiency. cost, latency, speed, accuracy. But in reality, we are designing these AI systems which are interpreting the people. They listen, respond, and shape how humans understand the technology. And increasingly, nowadays, how humans understand themselves itself, because humans are having a lot of conversation within the respective technology tools. That's why understanding these inner mechanics as designers and product builders is not only just technical, it is actually necessary to be ethical. Every product decision we make, every word we place first, every context we either keep or drop, it changes how the model interacts with people's thoughts and emotions. When you design with awareness of all these things, we are not just improving the model performance and user experience. We are building the clarity, trust, and respect into the interaction itself, which will result in better business. Now, we are designing systems that interpret the people, but are we designing for humans or machines? Which is it? I would say both. The more we design like the model thinks, the clearer our human intent becomes. As user experience designers, the same way we understood business needs and user psychology to design the user interfaces, we now need to understand these technical AI concepts and design for the model. The better we understand how the model thinks, the more responsibly we can teach it to understand us. The better we can design AI tools that provide greater experiences. Thank you for joining me in exploring how models see, remember, and focus. I hope this gave you some new insights and perspectives related to AI. We need to shape how intelligence feels in a responsible and ethical manner so we can provide great user experiences. Design smarter by understanding the technical AI concepts, build with awareness of all the concepts. When you understand all these mechanics, you will shape how intelligence feels, which results in great experience and great business. Thank you.